Good morning, friends. Today, in continuation, preparation of the alkanes. In my last video, I explained you catalytic reduction, that is catalytic hydrogenation, and the Woods reaction. Now today, I will give you more preparations. Reduction with zinc, copper, couple, and alcohol. Reduction with zinc, copper, couple, and alcohol. Very simple. Zinc react with alcohol in the presence of the copper to form the zinc ethoxide and the nascent hydrogen, that is 2H. This nascent hydrogen reacts with ethyl bromide to form the ethane and the HBr. Again listen. Reduction with zinc, copper, couple, and the alcohol. Actually, reaction takes place with the zinc and the alcohol in the presence of the couple. It forms the zinc ethoxide and the 2H, that is nascent hydrogen. And this nascent hydrogen reacts with ethyl bromide to form the ethane and the HBr. But actually, in this reaction, it was said that 2H is not as a reducing agent. In this case, there is a simple transfer of the electron from matter. Okay, listen. This 2H, nascent hydrogen, it formed the ethane and the HBr. But actually, it was found that in this reaction, 2H is not as a reducing agent. There is a transfer of the electron from metal, say zinc, give the 2 electrons, and these 2 electrons, they are taken up by the alkyl halide to form the halide and the alkyl, that is taking 1 electron each. And this alkyl then reacts with the alcohol in a way that alcohol breaks at the H to form the ethoxide and the hydrogen. So R takes hydrogen from the ethoxide to form the alkane and the ethoxide. So actually reaction takes place by the transfer of the electron from zinc. These 2 electrons, they are taken up by the halide and broken into the halide and the alkyls. So this alkyl which take electrons and then breaks the alcohol at ethoxides and the hydrogen and form the alkane and the ethoxide. This ethoxide then reacts with zinc to form the zinc ethoxide. Okay. Now, Greek not reagent. It's very important reagent in organic chemistry because it is highly reactive in nature. Actually, alkyl halides reacts with magnesium in dry ether to form the toxic magnesium bromide, that is a additive product, that is C2H5 MgPr. And it is very highly reactive in organic chemistry. It is used for so many preparation of the compounds. It very easily breaks with water and form the alkanes and the hydroxy magnesium bromide. So simply Grignard reagent is the reagent, that is C2H5 MgPr, that is additive product formed by the reaction of the alkyl halides with magnesium in dry ether. And this ethyl magnesium bromide is highly reactive and breaks or hydrolyzed with water to form the alkanes and the hydroxide magnesium bromide. Now one more reaction, that is decarboxylation and the electrolysis. Decarboxylation means removal of the carbon dioxide from the salt. So if sodium acetate is heated with soda lime, that is NaOH in the presence of the lime, that is calcium oxide, it forms the sodium carbonate and the alkane, that is methane. And if we take next sodium propionate heated with the soda lime, that is NaOH in the presence of the lime, it again forms the sodium carbonate and the ethane. Now, if you see in this reaction, the alkenes formed, they contain one carbon atom less from the parent compounds. See here in the case of the sodium acetate, two carbon atoms are there, and we get the methane. And in the case of the sodium propionate, it contains three carbon atoms, we get ethane. So in this reaction, alkenes formed, they contains one carbon atom less from the parent compounds. Now the electrolysis of the aqueous solutions of their salts, that is known as the Kolbe reaction. That is electrolysis of the salts, that is known as the Kolbe reaction. If we take potassium acetate, it undergoes this process in aqueous solution, it forms the acetate ions and the potassium ions. Now what happened at the anode and the cathode? This acid ion that goes to the anode and form a unstable CH3CO by giving out the electrons, and these unstable CH3CO, it form the ethane and the carbon dioxide. Now at cathode, hydrogen and the potassium ions are there. At cathode, hydrogen takes electrons and form the hydrogen which is liberated at the cathode, while the potassium ions remains in the solution. Again listen, in Kolbe reaction, aqueous sodium salt undergo electrolysis process. We take here potassium acetate, it breaks into acetate and the potassium ions. At anode, this acetate ions go there and form the CH3CO which is unstable. Then two molecules they join to form the ethane and the carbon dioxide. But at cathode, hydrogen and the potassium are there. Hydrogen join itself, the electron form the hydrogen gas and release at the cathode, while the potassium remains in the solution, and this potassium form the QH. So in all reaction of the electrolysis, if we say two molecules of the potassium acetate undergo electrolysis, it form the ethane, two molecule carbon dioxide, two molecule of the KH and the hydrogen gas. So today I gave you four preparations: reaction with zinc, copper and with alcohol, Grignard reagent, and the decarboxylation and the electrolysis process. So it is in continuation. In my next video I will give you more preparations. If you like my videos, please share and subscribe. Thanks very much.